Gravity will act in y direction. So in x direction, the component of velocity will not change. Vy will change. I have taken downward direction as positive y direction. Can you tell me how much is uy?
Sir, you said
Initial. Where is theta?
Zero.
0. Velocity is in horizontal direction. This is horizontal direction. So vertical component is 0. And ay is equal to plus g. Along x direction, there is no acceleration. So distance equal to speed into time type of thing. I can write Vx into t, but Vx is u, ut. If you want to find a relationship between x and y, then simply get rid of t. So t is x by u That's it. This is also a type of parabola. I would be interested in range when y becomes h, then x becomes r. So when y becomes h, x becomes r, and therefore this is r. If you have any questions, then let me know. Now let's do time of flight calculation as well. In x direction, we know that it is a constant velocity case. So for x direction, we can use speed equal to distance upon time formula, or time equal to distance upon speed. This can be used for x direction, not for y direction. So r by u is the time of flight, and that will be this much. Yes, now we have finished it, both the things, range and time. We also find the relationship between x and y, parabolic relationship. Any questions? If you have, then let me know. So let's proceed with further applications. So a small ball is kept here, very small ball. Other ball has to be projected from 19.6 centimeter height. This ball is to be projected horizontally. It should collide with this ball. What should be the speed? It's a formula-based question. U is asked, range is known, 2 meters, height is known. Can you try this?
So the speed compared to the approximately 4 meter per second.
So capital R is known. H is known. U has to be found out. Take G as 9.8 because this number 19.6 is 2 times 9.8. How much? The answer I have is 10 meter per second. If you have a problem, then let me know. This one is a typical projectile motion problem. We are assuming vertical wall to be tall, not like the goalpost type of question when the goalpost had a certain height. The wall is tall. So the only problem is that if it falls before that, that is the only case when it will not hit it directly, if it falls before that. But if its range is more than 5 or equal to 5, then because the wall is tall, it is going to hit it. Right? So just use the formula for the range and find out the range. See if it is more than 5, equal to 5, or less than 5.
Less than 5.
You are getting less than 5. If it is less than 5, then it is something like this. It's not going to hit directly then. Let me see. Can you recheck your working? Anybody else?
Sir, it is coming around 19.48, which would be more than a 5, and hence it would hit the wall.
So you're getting 19.5, nearly. Then it will hit. The answer I have is that it will hit. U square sine 2 theta divided by G. Just calculate that. Yes, 19.5 nearly. So the answer is yes, it will hit. It will hit. Something like that. Any questions? Let me know. Now it's like this. If your friend is here, and if you are throwing a direct packet towards him, then it's a bad idea. Why is it a bad idea? Because it won't go straight. Why won't it go straight? Because it is not a gravity-free world. In a gravity-free world, it will go straight. But because of gravity, it will have to bend from its path and it will land somewhere earlier. That's why I have marked this point. But then it won't be a straight line. The actual path will be curved path. Now if I show that path, it will become congested, but I can try. Maybe if I make this point somewhere to the left, it will be easier to show. So you can see that it's a very bad idea. Earlier I have been talking about the situation where an object leaves a moving thing and carries the velocity of that moving thing with it. Imagine a badly affected area in which food packets have to be supplied. People are here. Consider one person here, right here. This is the plane with relief packets. This is a plane with relief packets, and the plane drops a packet just when it was above this person, in a hope that the person here will get the packet. The plane is moving in this direction with certain velocity. That's a very bad thing to do. Any idea where will it fall? The packet in front of the person, before the person, or right where it was supposed to go?
Said to fall further towards the right.
And the reason is that packet will carry the velocity of the plane. Initial velocity of the plane the packet will carry. Right? It won't fall like that. Another situation, let me ask you, is this situation. Suppose a balloon is going up. Remember that problem we were doing in chemistry, the payload problem? This is some balloon connected to some containers, and somebody drops a ball from here. Just drops. And the balloon is going up. Ball is not thrown, it is dropped. Now tell me, will the ball immediately fall? Will the ball go up first and then fall? What will happen? Which of the two cases?
It would immediately fall.
Anybody else? Well, initial velocity is in which direction when the ball is dropped? Won't it carry the velocity of the balloon? And if it carries the velocity of the balloon is going up, so shouldn't the ball go up? Gravity will make it stop, and it will come back after that. So ball will go up and then fall and hit the ground. And now, coming back to this question. So one aims like that, gravity bends, and it falls here. How short will the packet fall? We want to know this distance. We have done couple of standard cases. One standard case, this one. Other standard case, horizontal projectile motion. But you can handle any problem by breaking it into components, any projectile problem. This is not horizontal projection, but no problem. Let's break the velocity into two pieces, initial velocity, like that. If this angle is theta, then we have u cos theta and u sin theta. For x direction, acceleration is 0. So we have distance equal to speed into time. I am taking downward direction as positive, right direction as, of course, positive. downward direction, S equal to ut plus half at square. I'm interested in this distance. So 228 minus that distance will be my answer. Let's get rid of t. It's a quadratic in x. Not a great sign, but one value should be rejected. Let's see. Now, if this is x, then y should be 171. Can you tell me how much is tan theta? (171 by 228). Let's take GS10. U is just a moment. Feet everywhere. G is 32. 32 by 2 is 16. U is 15. Cos theta is 228 divided by root of 228 square plus 171 square. Well, looks like time-consuming calculation. Any questions?
How did we get root of 228 square plus 171 square?
Cos theta is based upon hypotenuse. This is hypotenuse. But there is going to be a square, cos square theta. So the root will go. At least one thing is good, root is gone. But still, big one. If this thing is divisible by 171, our job should become little easy. 228 square plus 171 square. Is it divisible by 171? Yes, it is. Let me first copy this to the next screen. Two 228 square plus 171 square. Dividing everywhere by 171. Now let's make these numbers somewhat small. 228 is not divisible by 16. But 228 is divisible by 4. Two 228 by 4 is 57. 16 is 4 square. 475 upon 225. Both are divisible by 25. Can we make it simpler further? 228, is it divisible by 19? Just a moment. 19 3s are 57. And 57 into 3, 171. Okay, 57 into 4 is 228. That's not bad. So why not multiply by 228 everywhere? (57 into 4 is 228). 9 into 3. 27. Multiplying everywhere by 2 to 7. 27. 27. 6156 27x 4x square Okay. Now how do we solve it? Will factorization work or the direct formula? If anybody is able to factorize, let me know. And if you go for direct formula, obviously minus answer will give us unacceptable answer. X cannot be negative. So minus is to be rejected. So 27 square plus 16 into 6156. Nine nine two two five. Now, is it a perfect square? Yes, it is. (288 by 8). Is it divisible completely by 8? Well, things actually worked out rather well. 36. So can you tell me what's the final answer?
So 192 feet.
192 feet. That's very much short, isn't it? 228 feet was the intention. 228 feet range was desired. And what range he got? He got a meager range of 36 feet. So the packet fell short by a huge distance, 192 feet. It would have gone perfectly well had it been a gravity-free space. Any questions? Let me know.
What is the time taken?
Question is not asking the time. How short will the packet fall is the question. But if you want to find the time, that's going to be quite simple. Look at the top, x equal to u cos theta into t. X we have already found out, 36. U is known, cos theta is known, based upon hypotenuse. You can easily find time of flight. Yes, any other question? You don't have to answer it now. This will be your assignment question. And if you can give 1 or 2 lines for explanation, it will be better. Okay, I thought I would have to restart my system because of some Java problem today. But somehow it worked with some video problem little bit. Any clarification about this assignment? Let me know.
Are they fired from the same point or different points?
From the same place means you can take it as from the same point. Just adjacent point, let's say. Adjacent points. Same height, other conditions are same. Speeds are different, other conditions are same. Okay, so that's your assignment. We stop now.